Good afternoon, and welcome to our presentation about sea lamprey and invasive species. The purpose of this presentation is to evaluate the damages done to the ecosystems of the Great Lakes and its tributaries by sea lamprey, discussing why it's important to prevent invasive species from entering foreign ecosystems and to protect native species. The key points we will be going over are what sea lamprey are and what invasive species are, how they ended up in the Great Lakes system, and what solutions could and have already been put into effect to solve this solution. What we can learn from sea lamprey can teach us how we can protect our lakes and rivers from other invasive species in the future. What are invasive species? Invasive species are foreign species that were introduced to an ecosystem either through natural or oftentimes man-made means, in which they originally had no prior presence. This becomes an issue as the species will have no natural predators in their new ecosystem, oftentimes outcompeting their native niche as a result. There are many invasive species within the Great Lakes watershed, such as zebra mussel, cattail, and the common European reed. Lamprey are part of an ancient species of jawless fish known as Petromyzontidae. They are a parasitic fish native to the Atlantic Ocean and its tributaries along the American East Coast. Lamprey are often called eel, however they are not related to eel. Rather, their closest relatives are hagfish, another jawless fish. Lamprey have slender bodies and lack a bony skeleton. Rather, they have cartilaginous skeletons similar to sharks. They lack paired fins and have a sucker-like mouth with rows of sharp teeth used to attach themselves to fish, which they then use their piston-like tongue to puncture and scrape at the fish's skin, feeding on their blood and other bodily fluids. Lamprey are parasites that, when unchecked by predators, can damage the fish population. Lamprey are a major problem because of how much they can reproduce, moving upstream to lay their eggs, in which females can lay up to 80,000 to 100,000 eggs a year, starting as filter-feeding larvae before maturing and returning to the main body of water to feed off fish for 1 or 2 years. Sea lamprey were first introduced to the Great Lakes through man-made canals, mainly canal connecting Lake Champlain and Lake Ontario to the Atlantic through New York State. Their first appearance in Lake Ontario was documented in 1830, Niagara Falls acting as a natural barrier for about a century, until 1919 when the Welland Canal, as shown on the map, was deepened, allowing lamprey access to Lake Erie and, as a result, every lake within the Great Lakes system. By 1938, sea lamprey were found to be present in every Great Lake. This map shows an extent of the sea lamprey, with yellow showing their natural habitats and spawning grounds, and the brown showing regions in which they are invasive.
Why are they a problem? Sea lampreys deplete the native species populations by sucking on to other fish like parasites, which slowly kill them off through time. Overpopulation created a huge strain on native species, which in specific really affected the lake trout population. The lake trout within Great Lakes were one of the top predators, and without the species, the food chain wasn't complete. Along with these points, lampreys were also a huge problem in the commercial and recreational fishing industry. In turn, this caused a lot of economic damage. They're also a very quick species to reproduce, which is why their eradication has been so hard to do.
Sea lampreys are a major threat to the Great Lakes ecosystem, but scientists and policymakers are using a variety of strategies to control them. Let's explore the most effective methods. One approach involves building physical barriers and fishways in tributaries. These structures block sea lamprey migration, preventing them from reaching breeding grounds. Additionally, stricter regulations on ballast water could help stop their spread by limiting how they hitch rides into new areas. Another potential solution is introducing predators, such as non-native crayfish or otters, to control lamprey populations. This approach, however, carries risks. Take the cane toad in Australia, for example. It was introduced to manage agricultural pests, but instead it spread uncontrollably, causing more harm than good. The most effective tool we have is the use of lampricides, chemicals that target sea lamprey larvae in rivers. These treatments have been used since 1958 and can reduce larval populations by up to 95%. They are applied every 3 to 5 years and are carefully managed to minimize harm to other species. However, lampricides come with trade-offs. They're expensive and can have some environmental impact. That's why ongoing research is crucial to finding safer, more sustainable alternatives for the future. And here we have an image of tributaries around Lake Erie with records of lamprey infestations. So, by combining these strategies, physical barriers, cautious use of predators, and lampricides, we're making progress in controlling sea lampreys and protecting the Great Lakes for generations to come.
Lampricide doses throughout the Great Lakes. As seen on the graphs to the left, with the reapplication throughout the years, lamprey populations have begun to decline. In 2016 to 2019, a total of 57 retreatments were applied throughout the Great Lakes, with the majority of these retreatments taking part in Lake Superior, and the most retreatments taking place in 2017 at 15 total retreatments. Along with this, extensive stream treatment and lentic stream treatment evaluations have been taking place throughout the Great Lakes, with on average 100 assessments taking place per year between 2008 to 2019. Lamprey decline. As shown in the graph to the left, it represents the lamprey decline throughout all of the Great Lakes from the years 1985 to 2015, according to the Great Lakes Fishery Commission.
In conclusion, sea lamprey have been a major pest in the Great Lakes water system for nearly a century now, harming native fish populations and growing in numbers at an alarming rate as they spread across the lakes. However, new methods have been used to reduce the population size using lampricides and physical barriers. The methods used in reducing the population size and damage done by lamprey are an example of how we can mitigate and undo the man-made damages to lake and river systems, and it can be done in a safe and effective manner.
Thank you for listening to our presentation. Here are our references. Thanks.